Yeah, yeah, we are good.
Oh, nice. Oh, that's great. Sako, thanks for getting us together. We've got Girish and Tilo from Kinvolk as well. Guys, I'm pleased that we're recording this particular deep dive. We do a good job of recording our community meetings. And my hope is that all of the features and functions that we're working on are transparent and open, and we're encouraging of new collaborators, new contributors. And so when we first met with Tilo back at Cloud Native Rejects, which he's proudly representing today.
It's coincidence, but yeah, it's exactly the shirt.
There it is. He had just gotten done doing some rather intriguing work with respect to performance benchmarking of Linkerd and of Istio, and notably within the work was Tilo, you created a friendly fork of wrk2 to help facilitate some of the testing, and
yeah.
we were learning some things with respect to, well, one, coordinated omission, and then two, just kind of the approach that you guys have taken in general, and wanted to acknowledge that we'd originally chosen Fort.io as the load generator that's built into Meshery, really as one, as a matter of convenience and as a matter of familiarity to Istio, because that's the load generator that project uses. But then, after having been learned from things that you were describing, sounded like, hey, maybe the project will really benefit from the project, and the users would benefit from some of the work here. And so in that time, we put together a haphazard spec on what that might look like. And from our recent discussions, I think we're trying to figure out, hey, of the way in which Fort.io will report back statistics, it'll by default, or the way in which we're using it, it'll do it on a per request basis, and as such, and Fort.io has a few controls that we expose to users with respect to the longevity of the load that you want to generate, the not explicitly the number of requests, but rather the requests per second that you want to generate, and control over the number of threads. And so mathematically, you can arrive at a point by which you could say, hey, yes, here is the total number of requests that I would expect would be generated once the test began. And so the way in which we were presenting back these comparative performance, we were showing back the test results, and we were, what's most handy and most informative to, as you well know in the studies that you had published, it is the comparison between different types of tests that you're running and the variables that you've changed. And so to facilitate, so currently the comparative charts, performance charts that we will show are based on metrics that are gathered on a per request basis. And so to kind of catch everyone up and us up on our last point of discussion, I'm going to be quiet now, and I know you've probably got a couple of things to say with respect to that last challenge as we look at wrk2.
So in general, I believe choosing Fortio for the load generator initially makes a lot of sense for Meshery because of because of the focus and the kind of scenarios that Fortio enables you to test. wrk2. So maybe one or two words to the history of wrk. wrk is a HTTP load generation tool. It's out there. It's being maintained. It's a few years old, but it's still actively used, and it's pretty awesome. Now, Jill Teen, who's a dev from the Bay Area, forked wrk. So he himself made a friendly fork. wrk2 addresses coordinated omission, and only with wrk2 the requirement to specify a request per second was introduced because of the way wrk2 works. Now, going back to the kind of scenarios that Fordio lets you test easily, having individual requests, measuring basically measuring alongside a service mesh configuration, or maybe testing different application patterns. That's a lot more useful. And so it enables you to just run a quick test and get immediate results, whereas where Gelatine has taken wrk2 and given our own minimal changes on top of that, like I wouldn't even call it a fork. It happens to be in a separate repo because we didn't have time yet to clean up our, I think it's only 6 or 7 patches that went on top of where wrk2 currently is. So wrk2 lets you test a little more complex scenarios, and basically the atomic element that wrk2 has you test is not the individual request anymore, but a minimal load scenario for a given website. And you express that to wrk2 in terms of predefined requests per second. And wrk2 invests a lot of effort and tries to maintain this RPS rate, even when your peer is slower and runs into latency. That is, by the way, the reason why we've seen such hair-raising latencies that we've seen with our service mesh testing. I would not expect those to pop up much in real life. The reason here is to have a predefined scenario and to drive the maximum latency possible with any given system in that specific request per second scenario to the point where it's not bearable anymore. And so it shows you what you normally would not see with benchmarks, but what, I don't know, every thousandth of your user may experience. The longer you choose the test window to be, like it's not just a request per second bound, it's also dependent on the test window. So you won't see much of this in a 10-second or 1 minute test window, but if you run those tests for 5 minutes, 10 minutes, 30 minutes, and you're starting to see basically the outliers, and that helps you to identify those bottlenecks in your applications long before you run into any overload scenario with your users. So in a way, it is even if you keep static RPS, if you increase the test window, at some point in time, you just push your, there's chances that you'll push your endpoint to basically expose those kind of bottlenecks. And to take the 30-minute window and to transport that back in real life, the way wrk does its testing is best explained by the use case of having a web page being assembled at the user's end from beginning to end, and having the browser basically, in order to assemble that web page, emit a certain request rate per second. Now, no one will look at a web page that needs so many requests that it takes 30 minutes to assemble, but it will definitely, 30 minutes is a bit of a overdriven example, 5 minutes, maybe a better value here, but it'll definitely point you to the bottlenecks in your application way before anyone runs into it. So that's the maybe a simpler way comparing Fordio and wrk2 is Fordio is extremely fast and extremely usable for just basically testing basic things and testing response times on a per request level. That is something that wrk2 basically discards. It can't do that. wrk2 tests a scenario where the atomic operation is building of a website, for instance, in a client's browser. So I would distinguish, and maybe that's the value, the real value that wrk2 can bring to Meshery. Maybe I would distinguish between like individual, let's call it ping tests with Fordio, and complex scenario tests that you could execute with wrk2. And just to end the short friendly fork story that wrk2 has, so there's some limitation in guillotines in the upstream wrk2 in that even though you can spawn as many threads as you want, there's only a single URL, a single endpoint that you can benchmark. And we felt that was particularly, given that wrk2 aims at benchmarking scenarios, we found that unrealistic. And we basically, the 6 or 7 patches that we have on top of guillotines work just extends the command line options and the Lua scripting interface to be able to test multiple endpoints. So now you can define a scenario that will deliver a coherent RPS and latency report, and you can include multiple endpoints, and they'll all be accessed randomly during the measurement, and you basically get an overall result, which even more works into the direction of testing whole application scenarios.
Would it be a fair characterization to say that with guillotine's expansion to be able to test multiple endpoints and test them at different rates of load,
different endpoints was us. Guillotine did the awesome request per second work.
Oh, okay.
We just extended the Lua interface a little to make it work with multiple endpoints.
Oh, I see. Okay. But that then of your work, arguably the variable rate of load generated across those different endpoints is maybe more reflective of what you would experience in the real world, so to speak, as versus just this, this steady stream of requests per second for 5 minutes.
Yeah. So this basically, if you have a cluster application, it's likely that a request will access multiple services, multiple endpoints to assemble whatever is there to be assembled. So some minor feature that we were missing, which would be a few hours to implement, would be endpoint putting weights on endpoints. So basically saying this endpoint needs to have a, I don't know, 40% chance to be called, and distribute endpoint weights like that, which would even more enable people to just build complex scenarios, complex test scenarios there. But we didn't go there because we didn't need it for the service measurement parts.
Yeah, no, but that seems quite interesting in so much as you would expect that an operator would be able to say, yeah, hey, look, this is our or of the 10 services that we have, it's the authentication service that gets hammered every single time, or it's this one that people use the most. So we want to generate 80% load or relative, considering those 10 services, here's the relative load that we'd like to generate across them.
Exactly, yeah.
That seems, from my naive perspective, that type of an enhancement seems relatively straightforward. Would you characterize it as such? Do you think that that's a...
Yeah. It could be, like, I mean, the most straightforward implementation would probably be adding 5 or 6 lines of Lua code and then call it done. But I mean, it needs to be implemented and be tested. But yeah, it's not much. It's not much work to add that to the on top of wrk2, what we did. However, so the state our fork is currently in is highly specific to the benchmarks that we've run. We've made a number of extensions. For instance, if you want to supply multiple endpoints, it's done in a little peculiar way right now. It's not like the obvious thing on the command line that you would expect. And before committing our work upstream, or before starting to basically extend on that work, I would rather have someone spend a few days and cleaning things up and making the features we've added more generally usable. That's not much change as well. This is actually mostly design, so it's not even programming. It's more what should the command line interface look like for multiple endpoints? Because now it looks horrible. I'm being honest here. I wrote it. People can use it, but it's nothing I'm particularly proud of. So this needs a better, more thorough thinking, and basically while doing that, the weights could be added on the side that just would, yeah, it would hit right the same sources. So
got it. What's the programmatic interface to I haven't even to wrk2?
So there is a scripting interface to wrk2 where you can basically write Lua hooks for certain states that each of the load generator threads is in, and that's, I mean, they basically provide access to internal data structures, the hosts they're about to connect, or if it's a callback after a request finished or before a request starts, it'll give you the HTTP header so you can tweak if you implement a response hook, then you can basically get the results and the HTTP response and whatnot. wrk2 does only the most minimum of HTTP parsing because it tries to be very fast. So it's not even fully HTTP compliant. It just does the most basic things necessary to work as a client and as a server, to work as a client and to process server responses. But other than the very specific Lua interface that lets you write scripts for basically stages that the load generator threads go through, and there's no like controlling API where you can give the thing commands. It's just being fired from the command line currently, and then it just does its job.
Okay. I'm gonna make a suggestion, and maybe I'm leading the answer here, and this is not. But to the extent that, and maybe this is already available, but it seemed like last time that we had engaged on the in chat that that wrk2 didn't emit or didn't natively emit those statistics in JSON to the extent that that was desirable within Meshery to fit into the existing charting framework.
Mm-hmm.
In your mind, is the most appropriate place to hook to augment that? Would that be in a Lua script that hooks into the response server?
The right place would be in a Lua script, and so there are more hooks available than just for the worker threads. You also have a startup hook that basically is called from the context of the main application, and then you have a results hook at the very end of the test run, and you basically get access to all of the raw wrk2 results. And there's actually, I believe, I've seen an example Lua script in one of the upstream WRKs that does just that. That gives you JSON output. That basically takes the Lua data structures and just prints them on standard out in. Well, there's no JSON library used, but it's basically JSON format.
Nice. Okay, that's inspiring, or that's confidence building. As being an easy way to. I'm gonna be quiet here because I know I didn't let so both Garish and Saklar have been looking at this a little bit. So
yeah, sure. Yeah, I guess that was much clearer now. So one thing, as was Lee mentioning, the JSON, it's still in the WRK. It's still in one of the PRs. We just pulled that one and tested it was working. So in wrk2, do you have similar or?
Yeah, so wrk2 is almost exactly wrk if you look at it from the outside, with one major difference in the command line interface, and that is wrk2 requires you to specify a request per second, because that's the way the statistics in wrk2 work. Mm-hmm. WRK doesn't have that. I don't think WRK even takes the RPS command line argument. That's something that's been introduced by Jill. And the main difference internally is, of course, that internally basically Jill's histogram code and statistics code is being used for measuring latency, which is not what wrk does. So wrk has no concept of coordinated omission. It's simply benchmark.
So there is in wrk the thread connection and the duration. There are three things, and on top of wrk2, you are saying there is also RPC on top of this. That's as input we can specify.
Requests per second, you have to specify requests per second for wrk2 to do its job. I think wrk doesn't take RPS.
Yeah, there is only three things in wrk. And when you specify multiple endpoints, but then these all four variables apply to all of the endpoints, yeah?
The request per second, so that's an extension that we introduced. If you specify multiple endpoints, it emits the overall request per seconds as a sum over all endpoints.
Oh, okay.
And it also gives you the sum of the latency over all endpoints. You get a per endpoint. I believe you get a per endpoint latency. If it's not added, it's easy to add in Lua. But yeah, so this is what I meant. This is more focused on testing complex scenarios.
I see. So if in case we put in the JSON format, which is from the upstream, so it will be included because it's raw result. Latency per endpoint may include there too, yeah.
I'm not sure if I'm rather sure it's not in yet, but it should be it shouldn't be hard to basically retrofit that. So this needs a little bit research in the result data structures that you get from wrk2. If like in the worst of cases, the Lua API needs to be a little bit extended to get like more data and more access. So just to stay on the safe side for now, I'll say that our modification lets you measure the overall latency distributed over all endpoints.
I see. And yeah, in this case, so basically, and as you said, there is no any REST API or something that's already something you have done, yeah? That's basically...
Sorry, come again? Could you repeat that?
So basically, we have the backend, which is in Go, that we purely gonna give the inputs to the through the command line and get in JSON output and push it to React front end.
Yeah, that should do it. And so generating the JSON output will be a minor work item, but there's an example Lua script that guides you to basically that goal, so that should work.
Yeah, if you can share that which guide can help for.
Let me actually look it up right now. I'll keep listening.
Yeah, sure. Yeah, I guess. And the best way at this point is calling through the command line. Yeah, that's bring the container inside and run it.
Yeah, basically the easiest way to interface with that is put it as a binary into the same container and do a call executing that and then wait for it to finish, and then you basically get the results from after it ended.
Okay. Yeah, and the last question. So you guys gonna PR your work into original WRK, and
we will eventually. So I have a few ideas because the state of things currently aims specifically at the service mesh benchmarking we did. So I need to work a little on the command line interface, make it a little more generic and easier to use. But yeah, we're definitely planning to get this back upstream because that's where it belongs from our point of view.
Okay. So the best advice you would say for us to right now pull from the wrk2 rather than wrk, and once you merge, change it, or?
I would work with wrk2 with Giltine's upstream repo, which currently has the limitation that you only can benchmark a single endpoint. So because our work is not included yet, but everything's there from basically the runtime side, and I think integrating that would be a very good foundation for later on iterating on the integration and then support multiple endpoints and things like that.
Okay, which on this case will be single endpoint, but you will have another RPS as a input variable.
Which one? Giltine's wrk2.
Yeah. So the main advantage is going to be the RPS at this point then.
And sorry, could you repeat?
Only the RPS one will be the main.
Correct. So you will need to specify requests per second, and this will take the benchmark will take coordinated omission into account. So you can really like press your endpoints and see where it gets bad.
Okay. Once a coordination omission to me, I'm not so much clear. If you can briefly coordination omission,
what it is?
Yeah.
Coordinated omission. This is like one of the main reasons that that we picked wrk2 for this kind of benchmark. It's a relatively new thing. Like if you Google for it, you only find a few blog posts. Most prominently by Giltine, who came up with the concept behind that. So in traditional benchmarks where you do not specify a request per second rate, but just say, you tell the benchmark, okay, there's your endpoint, give it what you got, and then give me like the rough RPS the endpoint can take. The thing that the benchmark will do is it will issue requests, wait for responses in a mostly synchronous manner to give you a average and a percentile of the latency that you might expect. The thing that this kind of benchmarking omits is a user or a browser wouldn't wait for a specific request to finish until the next one is being issued. Now, this has an impact on the way that results are reported. So for traditional benchmarks, imagine you have a theoretical request per second rate of let's say 10 RPS. So the benchmark, the load generator will just issue the requests, and just imagine one response. So it needs to basically issue a request every 100 milliseconds. And let's assume one response takes 300 milliseconds. And the way this will be reported in the results is 9 requests went very well, but a single request was an outlier and took 3 times. So you're kind of motivated to just remove the outlier because it's just one outlier, but your user will feel differently. So Mr. Teen theorizes that the user would issue the next request even though the current one has not terminated. And that does 2 things. First, the next request isn't late in the scenario I just described. The next request would be issued 200 milliseconds too late. So issuing a request is already late. And that means the next request would be late in the response as well and should be counted as such. Even if it's below 100 milliseconds, because it's still slow for the user, because the overall thing takes 300 milliseconds. So wrk2 additionally takes the time into account, the point in time into account at which the next request should have been issued, and it adds this to that request's latency. And that, by the way, is the reason why some of the service mesh benchmark results look so bad that we publish, because obviously latency is piling up now. It can't escape anymore. If the server falls asleep for half an hour on a single request, then this half an hour will impact every single successive request if you take coordinated omission into account. This does not happen if we just run, simple one after another request.
I see. Yeah, much clearer. Yeah, I'm goodly. Yeah, thank you.
Nice. Just to clarify, Sako, right now, do you have JSON formatted output from wrk?
Yeah, I can go and run.
Okay, and that's okay. And
Yeah,
actually,
I think I posted also in the. Let me quickly. Yeah, that's.
no, very good. And I don't need a proof point, but just yes, the answer. That's great. And so, and we're not explicitly not.
I have it.
And that's fine. I just need for you to say yes or no.
Yes, I'm gonna just
Very good. And I actually don't want to see it. It's okay.
No, it's just wrk. Just it's not wrk2.
Yep,
it's just wanted that see if we'll have any difference. So that's one. We are currently.
Yeah, got it. Great. And that's not
what I want. Oh, so interesting. Cool.
Cool. But yeah, and so great. So in wrk is explicitly not what we're interested in working with, but wrk2 for the reasons that Thilo expressed, and actually explicitly probably Thilo's friendly fork, given the efforts that given the fact that he's focused on much of the same thing and went through some of those pains. The multiple endpoint thing is pretty neat. Actually, it leads me maybe to my some other questions. Is Thilo, last time we spoke, it was, well, I think one at the time had, well, if I recollect, maybe relatively recently joined at Kinvolk, so maybe still within a year it'd be great. And then there was some thought toward, well, I guess a couple of questions, like there was some thought toward continuing to advance the efforts there. I think trying to merge the fork that you have now into Jill Teens back into wrk2. Where has your focus been since last we spoke? How has your relationship with Jill Teen gone, or is that looking like it's going to merge, or
So the unfortunate truth is I didn't have much time yet to put any work into wrk2 to basically polish it. I'm planning to look at this in the next weeks, but so the reason I joined Kinvolk is that we're looking at some growth, and particularly if you're in a management role, there's like a lot of work. So I currently have quite a bit on my plate. I'm not sure when I will finally come down and be able to actually implement that. I have a few ideas. So I wouldn't make that a hard dependence, because I can't give you a good ETA that you would be able to rely on. I don't even know Jill. I just read a lot of stuff from him, and like a lot of things made sense in terms of benchmarking. I have a bit of a testing benchmarking background. Before I joined Kinvolk, I worked for Amazon EC2. We have a kernel and hypervisor team in Dresden here in Germany. And we also did a lot of scenario and system testing, automated. So there's a little bit of, I have a little bit of practical background of the statistics, and it felt like a lot of things fell into place and went click when I just read the theory behind coordinated omission. And yeah, so that's my current status. I was on vacation for 3 weeks as well, so I get my time off. But I mean, we were in a motorhome, and we were touring all of Sweden. So yeah,
very nice. Okay, yeah, rub it in while you're just keep going.
Yeah, so I'm more or less back since a month and picking up stuff and trying to make projects happen. But
Totally.
apart from the occasional benchmarking or actually mostly benchmarking spikes that I have, that's only 1 or 2 days. Completely unrelated to service meshes or HTTP, I haven't done any engineering work. Like I was mostly focused on management work.
Yeah.
So I'm sorry for my original plan was to have the pull request for the upstream wrk2 polished and ready after KubeCon, but for some reason that kind of didn't work out. So here we are. It's still in planning stages.
It's the sad life of an engineering director.
Yeah, it's not just suffering, it's mostly fun, but things I want to do and that are highly engineering, programming specific, I sometimes don't get to do. That's just...
You get to talk about all the fun everyone else is having, and that's like...
Yeah.
Okay, it makes a lot of sense. And then, you know what, I probably missed it there, but did you say that you think, or as we go to consider how we might be able to fit in the fork that you have now, did you say you think that it might get, or no, there's a bit of cleanup that would need to be done before you think it would be accepted back into WRC?
We haven't opened the PR yet because in the current state, I just wouldn't want to do that. And it's not, as I said, it's not much work to get it into a PRable state. I am absolutely ready to have that discussion upstream. And I think the fact that upstream WRK2 already does some kind of scenario testing, because you need to specify requests per second, and it's not a per request benchmark anymore. I may have a good story for my change to get in. And the second thing that makes me more positive about the chances we have to get accepted is it's not much of a change. Like there are a few minor items that need to be fixed in WRK2 and in the C part. When you start when you want to connect to different hosts from a Lua script, and I've done those fixes. Then we basically supply the multiple endpoints options in Lua script. So that's not even a core WRK2 extension. So yeah, I'm very optimistic to getting those merged.
Yeah, right. Are those like is the multiple the definition of each of those endpoints, is that given that those are defined inside the Lua scripts, are those bubbled up to the WRK2 CLI? Where you
yeah. So, and this is particularly the kind of ugly part, that so the way it's written, the way it's implemented right now, you supply a number of URL templates that contain a pattern in the template that you want iterated or replaced. Okay. And then you as another argument, you supply a count. And what the Lua script then does is it extends the templates list covering all of the counts. And the simple reason for that, for writing it this way, is so we had the same application deployed with different names in order to kind of mimic a higher load cluster, a more complex cluster. So you had application URLs like app1, app2, app3, app4, and and this is what was generated inside of the Lua script. You gave it basically the basic URL pattern and the endpoint you want to test it. And since it's the same app, it's the same endpoints across all of the enumerated apps. And that's why I say it's extremely specific. And I just want to rewrite that to be more generic. So you can just give a list of HTTP endpoints in the command line options and call it done.
Yeah, right. Then refresh my memory as well. Like the bit where now that you're doing multiple endpoints, and I think if memory serves, the bit where when you did the at scale tests, you had multiple instances of your wrk2 fork running. No, okay.
No, it was a single. That is some future extension we were using at the end of the blog post. That'll take significantly more effort, but would provide significantly more value if you want to benchmark clusters, to have basically a distributed wrk on multiple nodes. So to be able to benchmark larger parts of your cluster. We were able to kind of circumvent that for the benchmarks for the service mesh benchmarks by keeping the cluster at a relatively small size and just stuffing applications in it, and also making sure that all of the machines and all of the networking bandwidth is sufficient, so we don't need to scale out, but can basically scale vertically inside of a machine. Scaling vertically is implemented, it's just using more threads.
Okay, yeah, sure. But then horizontal, like distributed workload or load generation is. But then you're saying I think you're also reflecting on how the assimilation of all those results and then the crunching of those numbers to produce the report, like the in part because you ran X number of tests with lots of results per test, and then,
I know what you mean.
That's just still a manual, or like, hey, you've got there's
This is above wrk2, so this is outside even the container images we've built, and that's more or less scripting based on the raw wrk2 benchmark output. To give a little more detail on what we were doing there is and that's something I learned with Amazon, who has considerable sized data centers. If you wanna benchmark and get something that's representative, and that's what we were aiming for the service mesh benchmark, right? You shouldn't rely on the data center placement algorithm to pick a good server for you, particularly for network benchmarks. And you need enough data points to make sure that you're not looking at data for a like Goldilocks cluster where everything is in the same rack, and also that you don't have any lemon hosts where, I don't know, one of the two network interfaces happens to be broken or of less performance. So we tried to get enough statistical distribution of all of our data points, and so we ended up basically running the same tests on 3 different clusters in 3 different regions, and then executing the same set of tests, I think, 3 times per cluster. So we had a time, we had basically redundancy in time, and we had parallel redundancy, and that gave us, I think, 9 data points total. And this is, by the way, this is something that I dearly missed in some of the benchmark blog posts that I've read. In order to be comparable to other people's clusters, to other people's data, you need to make sure not only to get the results for your particular installation, but you also need to understand, in a similar setup, in the same or a similar data center, what's the variance of data points? Like, what's the deviation that you have? If you look at the value, what are the lowest and highest values for the same test that you've ever seen? So in order to even start to be comparable to other people's measurements, you definitely need to execute those tests in a number of different places, servers, to just make sure to have enough coverage in your data.
And that, like that last bit about low and high, identifying your low and your high variance and the results you're getting back, that's to be able to, one, I mean, in general, what you're describing is like, hey, if you're going to have any confidence in the results you're going to report on, you're going to want to have some amount of statistical significance that says, look, we ran this thing 1,000 times, and we've put out the outliers, or we've excluded those, and here's the outliers in terms of the test results, not in terms of the that's important what you're saying, but I think you're also saying something slightly more nuanced within there, and that's to say, look, so that's great in terms of confidence in the results that you're producing, but if you'd like to say, hey, look, and this other teams or efforts results are, here's how we can compare those, you're saying like, hey, you do well to be, you got to start with at least identifying your low and high watermark in terms of variability between from test to test. Like, okay. And that's again a confidence building thing, right? Like, hey, we have this much variance between tests, so we're pretty confident. Like, the environment was well secure. It was a tight vacuum, if you will. Like in some respects, even if that network interface is screwed, like it's been screwed the whole time for every single test. It was the same interface that was screwed. So, granted, you're going to want to know that but okay. So that makes sense.
You would identify particularly the broken network interface because a different cluster would generate vastly different results. So you could easily identify that outlier, and something that we didn't do because on overall we didn't have the time for that. But basically, do deep dives on specific failure modes that you've only seen in a single cluster on a single host. What we actually did, I think we had that once, and we were not sure what was causing it. We just basically destroyed the cluster and redeployed, and then it was done because we were on different servers. So,
yeah,
but yeah, of course, that would. And the other thing I find important, I mean, confidence is of course paramount, particularly for this kind of benchmark. The other thing I find equally important is usability for others. Like the other thing we're trying to establish is to give that data out and to have people look at it, and maybe the whole like service mesh benchmark automation is also open sourced in a separate repo, and give people the opportunity to rerun that in their scenarios and to actually have something they can compare their own values with, right?
Yeah. You have taken the words out of my mouth that I've said. Yeah, I totally agree that, like, in some respects, myself as a user coming to this would say, well, that's fantastic. You've got some Kafka thing that's running such and such. That isn't like I'm running something totally different. By the way, also you're running in AWS on Windows machines where I'm running in GC. Like I could like that's interesting from afar that like you generally see this much overhead and it looks like that to you, but I kind of don't care because what I really care about is within my environment. Moreover, I care about it one time, not just one time, but like ongoing. Like what's, am I still doing as well? Am I improving or am I going worse? I get that's along the lines of something I wanted to ask, which was, given that the at least from my perspective, that the work that you guys have produced and published was as well received as it was. You've begun to articulate a couple of learnings that you've taken from the feedback that you've gotten. I know you literally got feedback from the Istio from Mondar and other folks, but in terms of like tuning the config and yes, we're like keenly aware of these things. We're going to try to be all encompassing in terms of but any other, like you just articulated one where, okay, a couple of questions. Any other ahas that you had? Any other feedback that you got where people said, yeah, gee, if you really had just shown me a failure mode in terms of like some component going down, or in terms of the fact that I'm doing a redeploy of the same app at the same time, like what does that look like? Or the fact that I've got maintenance going on, just like if you catalog all that feedback, like where did the results resonate the strongest with people, and you got a lot of positive things, and maybe where did you get feedback where people had said, here's what you didn't consider that would have been really helpful to me.
So the truth is we didn't get that much of direct feedback. There's a number of people seem to have picked up both the service mesh test automation and basically the wrk2 work with it because it's using a container where that is supplied. In general, I think we got a few responses from the Istio community, which we're very thankful for. I mean, they obviously, given the way we've measured, and I've detailed that previously in this meeting, is a very aggressive way, and it really tries to push the boundaries, right? So I don't mind the occasional like lapse in communication that just happens, right? If you face those results and they look funny because you've never seen something like that before, which basically just has to do with the way we're measuring taking coordinated omission into account, which people usually don't seem to do. Apart from that, we got feedback on like what we consider the default Istio config, which the Istio project has put up particularly for evaluating Istio. There was a little bit feedback to the Istio community that actually happened in a discussion on the service mesh benchmark GitHub project that they kind of adjusted their documentation. So if you use that configuration, then you're absolutely aware it's actually optimized to, for instance, work on the 3-tier AWS stuff, right? So it's that minimal that you can run it on a T3 Nano or whatever it currently is in 3-tier, just to get an experience. And with evaluation, they just mean the development and the programming side. Just have a look how this is configured and how this operates.
Yeah.
We also had a tuned config right from the beginning, and we had someone review the tuned config and actually identify a number of shortcomings in that config where we, I believe, put memory limitations on some component of Istio, which he argued didn't have an overly much influence on the results, but still could be improved. And we improved that, and we actually reran the tests after that, and we updated the blog post. It basically just caused the latency to go a little down, but not significantly, so the verdict of the blog post remains. And it, of course, because we removed memory limits, it made the resource usage go through the roof. So it's always a trade-off. On overall, I'm actually very happy with the interaction that we had with the Istio community in particular. Like most of the interactions were very helpful. We have a document update on the Istio website regarding the evaluation config. We took a few hints from someone very knowledgeable with tuning Istio performance in order to generate the perfect config that we then used for improving our blog post. And that's all basically things that made the blog post more useful for others. So that was okay. Other than that, we didn't actually have much interaction. So that was the most of it. We had someone theorizing whether the benchmark would be at some point CPU bound. It wasn't for the kind of large servers that we ran those on, but I mean, sure. That's something definitely worth theorizing on because this kind of thinking brings you into the next step, which is making the whole thing distributed, right? Because that's the best way to overcome single node limitations.
Any feedback? Oh, I guess along those same lines, any feedback that you got on running the load generator in cluster as versus external to cluster?
No, that just it caused a little bit of confusion and a few misunderstandings at first. But after we've basically stated that, we clarified that. For instance, one of the suspicions the Istio folks had regarding the high latency was the configuration of the ingress nodes. for Istio. And we could basically address this concern by saying, no, we're basically testing in cluster because we don't want the ingress nodes in the critical path. So this was just for looking at service meshes and not that looking at service meshes in combination with ingress nodes. So, but we didn't encounter any like larger confusion that in this regard.
Yeah, there are. This is Attilo. It's been too long, man. I got 5 more questions for you. This is fantastic. One, there's this. Well, we haven't. I'm going to put a link into the Zoom right now. We haven't advanced it much beyond this conceptual phase that with some of those same Istio performance or folks that are working on performance, and with William of on the wrk2 project, and with some of the console folks and some of the I don't think we got the app mesh folks as far as this, but also with the Octarine folks and the networks, with the networks, the NSM people, that there was an agreement that a conceptual agreement that would be beneficial to if for each, so we're at some point when Meshery reaches an MVP of like, it is in fact quite useful and there's bug free, and whatever that MVP is, that a number of them are looking at taking Meshery and running it within the projects themselves, like as a regression test for releases. And in doing so, they also, obviously, William of Buoyant considers that this is a sweet spot for wrk2, at least at the moment, in terms of like showing up Istio, and so clearly he's inclined to, and that's fantastic, awesome. Yeah, I totally encourage him to go like beat Istio, beat whatever, like I encourage all of them to go use whatever weapons they've got to go, or do their thing, that in them potentially picking up the Meshery as a utility for their ongoing testing is to facilitate I'm going to use the term extraordinarily lightly, a standard result spec, if you will, that just really, captures 3 things. It captures literally the output of the results, or the results themselves. It captures just the config of the environment to say, yeah, it was all T3 nanos and whatever and then, and here it was at 10,000 RPS for 20 minutes or whatever and it's so that even though it's still like not going to be apples to apples across the meshes, it's still about as close as you can kind of get to saying, okay, well, here's 2 independent test results. Here's them at least using the same format. So I'm bringing this up and explaining it in context of a couple of questions around your ongoing focus and us hopefully, or me or us hopefully delivering on some of the things that we said where, hey, coordinate omission. I had the same question Sako had, which is, what the hell is that? And can you explain it 4 times on a whiteboard to me so that I can, so I can understand that? And hey, maybe we should talk about that some more. You guys have talked about it. That's fantastic. Hey, maybe we should do a blog. If we get through this effort here, maybe we should do a blog post. And so I'm hopeful there that as we move forward, that we'll have something interesting to parlay on and to have you come and explain it for the 9th time to the rest of the world. And then
it's just improving my explanation, like wording and skills. I'm actually very happy to do that, particularly given that Word hasn't gone around that much, at least if you look via Google.
Yeah, which then has me wondering, of the automation suite that you guys have that's there now, I assume that's about in the same place that it was previously. Is there still an intention to go and try to advance that, or the reason, I guess primarily the reason I'm asking is, or hey, should we or we either be encouraging of, and or at any point are you inclined to collaborate even more within Meshery than we are already have been spending time doing stuff?
we need to basically think this through in a coordinated way. But just as a generic answer, we'd absolutely be interested in work on Meshery. The thing that regarding the test suite that we have and that we've published, this is it's also strongly focused on basically the service mesh benchmarking work that we did. It's using our locomotive Kubernetes distribution, and it's a bunch of shell scripts basically that do all that pull like most of the prerequisites that you need, and that just call basically that execute locomotive jobs to deploy clusters, and that then interfaces with Linkerd or Istio client side to just tune and then deploys the benchmark pod to run the benchmarks. So it's while it's a number of well-maintained shell scripts, those are highly specific to what we needed for the benchmarks. I think they are usable for people to at least reproduce the results that we have, even with newer versions of Linkerd and Istio. But for a more generic use case, I would definitely go more the Meshery direction and not make this something outside of a cluster that basically interfaces with cube control and with the stuff, and then to orchestrate things in the cluster, but make it cloud native. And I mean, that's where Meshery already is. So that's definitely the right thing to extend for that. Something that comes to mind with regard to having individual test runs on what's technically the same infrastructure but has been deployed in separate data centers. And if you think about the power and the degree of freedom that one would win with having an in-cluster application that does those kind of benchmarks, maybe a future direction this could go is to allow people to submit their results. At first, to have a generic benchmark load that's reproducible across clusters, and then to kind of submit their benchmark results anonymously or not to a central repository where people can basically look up scenarios. And so if they're looking for a specific configuration, then they would basically see if anyone anywhere has already run a benchmark in that configuration and could use the benchmark results as a hint and as a comparison, and how, like, for instance, different cloud providers and different Kubernetes cluster scenarios compare.
Sold. Yeah. This is, I don't know if this is exciting or annoying. You've taken the words out of our mouths again. Or yeah, like
wow, okay.
Yeah. No, I mean, and it's exciting. It's not annoying. It's that's been something that it's, I don't know, or moderately frustrating that that the effort that folks have put into Meshery, that the project, that the community has yet to get to a point where we've been able to do a public service that you're describing in terms of highlighting the fact that it does that today. As a user, you go download Meshery, you go run a performance test. It will, in an anonymous way, bundle up essentially that benchmark spec, that last link that I was sending to you. Not all the info, we've still got a couple of items to implement, but in concept, basically, bundle up the test results anonymously, send them back to a free tier account on AWS, because it's a community project, to then do exactly what you've said, which is to say, and then you actually articulated it well in terms of like, not only just like, hey, can we begin to say something like, look, 2,000 tests have been run across all the console deployments. It costs you on average, just, all variables included, 5% overhead, or whatever you know, like, and there's a couple of things that I think can happen out of that. One is for them to look at their results and say, well, I'm writing at like 1.5%. I'm doing good. Like I've got an A+, like, you know, this is great. Like I don't have to be concerned, or not. I've got an F, you know, I've got a, but then, and of course there's like a ton of variables to be accounted for, but when you get enough of those, that if for nothing else, you can just say like, look, the very worst of the 2000 was 10% overhead. That's the worst you're ever going to have, you know, or conception. Anyone would ever have the running a mesh anywhere. Like, okay, well, that's onto its own. Just that's an interesting, you know, and also doing it in context is something like, hey, actually, yeah, there are standard profiles that come preloaded in this case in Meshery that right now it's a couple different sample apps. The same ones that and also here's some load generation profiles, if you will. Here's the maximum blast everything until something falls over and stops responding. Here's the one that's a light, you know, here's Black Friday profile, here's the other profile, you know, and to have those be sent back as well, or in that same form, so that you can then say, I think in part to what you were describing, which is like, I've got different I've got different load test profiles, like, you know, and I've got different application signatures, application profiles. Here's a database intensive one. Here's a event bus centric one. We're working with a couple PhD students here at the University of Austin, Texas, and their professor, and then two more and their professor at Cornell, who's produced. They've open sourced a social network app. It's intended to sort of look kind of like a Twitter or like any of the number of social apps that we've got out there, and then but be complex enough that it's not an emoji voto. It's it's like 10 different. It's a horribly designed set of microservices actually, but it kind of doesn't matter because it's still kind of valid because there's lots of people that design their stuff horribly, and so just so long as you're saying this is what it looks like, hey, it's still valid.
The only thing that needs to provide is to have a comparable to basically have something comparable. Even if it's awful, it's awful in all clusters. And you're more interested in the differences than in the actual performance of that particular application.
So I'm sensitive to the fact that we're like 15 minutes over the time that we have. So there's maybe to wrap up. You already have the vision for some of the things that we've been saying, like, hey, some of those things we were able to put in effort toward initially, and like some of those are in play. So yeah, hey, today it's sending back anonymous reports of now that said, there's some work to be done there to make sure that, in part to the point that you were describing before, that you're statistically significant, or you've got the right info to be able to actually make meaning of it. Two, that anyway, actually, one thought that occurs to me is that if you guys were, one thing that, as we keep talking, if there is thing that we might be able to do, if you were amenable to it, if it was beneficial or you considered for the benchmark test suite that you guys have now, those set of scripts, which in a beautiful way uses Locomotive Linux and your Kubernetes distro, is to potentially help format the results that it collects into that other benchmark spec, such that as people take your test suite, run things, those results too could be would be made available to could be made available to you guys as well, along with the ones from the Meshery, to be able to that, in my mind, would help strengthen the validity of the results that are presented. That there isn't just one load generator test suite that's doing this, but there's another one that's taken, as a matter of fact, especially if we aren't successful or don't get to, and I think we will be, but if we don't get to the having a coordinated omission capability, like if this one's doing the 4.0 way and this one, like that's even more fantastic in many respects if we were to augment your test suite with those same type of results. That's
the thing about our test suite, so as I said, it's highly specific, and given the state that Meshery is already in, and given that we would usually it would usually take a customer assignment or something similar to cause us to put massive work into the test suite. I would argue that next time around, your approach to run benchmarks, you basically just use Meshery. So that's probably the more beneficial to use and to extend, obviously, because that's the second benefit there. It's all out in the open, and if you need a feature, if you need a change, you can just go and propose it. Yeah. So while I see a future for very specific kind of tests with our own benchmark suite, I don't think it has a great generic future given the state that Meshery is already in.
Yeah, well, and that's another. As I put myself into Kinvolk shoes, yeah, one thing that as you go to potentially engage or just the more of these conversations we have, I'll say this in a different way that so Sako and Garish, you guys know that who was it? Was it Nuno that was demoing here recently the provisioning of K3OS I don't know if he didn't do a micro K8s, but just anyway the notion that there was we'd been focusing on kind of Minikube and Docker Desktop and some of these, but Locomotive Linux or other environments that are more that like, hey, yeah, those would be great things for Meshery to be able to make sure that it's compatible with and can help facilitate the.
So Locomotive is the Kubernetes stack that we are maintaining. It's powered by Flatcar Linux. That's the underlying Linux distribution, which is a friendly form of container Linux. And we are of course continuing that, even if container Linux should be discontinued at some point. Yeah, but we actually, so given a good reason or a good opportunity, there's a lot of interest at Kinvolk to, for instance, add Meshery as a Locomotive component. So it can basically be added, or it can even be made default for certain cluster installs. So yeah, absolutely. Regarding that particular roadmap and timeline, I'd like to pull in Chris because he knows a lot more. He's basically the visionary regarding the whole Locomotive thing, and he can basically interface a lot better with you folks to just basically iron out wrinkles and make everything happen. So yeah, reaching out to Chris, if you could do that, if you're interested in Locomotive and into a Locomotive presentation in this particular forum, then absolutely I'm pretty sure he'll pop up and he'll fill us in.
Yeah, that's nice. Yeah, I in the office that I'm sitting in right now, I've had Chris out here in this office. We've had lunch here, so it's as a matter of fact, I think when. As the guy's been he might be challenging you at some point with like the beard length, man. He's
Chris I'm cutting mine. Like this is like the length that I like, but Chris is not stopping. He just lets it flow. It's amazing. And yeah, looks pretty good. That's Chris currently. So people will see him again to KubeCon latest, and then everybody can just measure how far it got. But it looks pretty impressive already.
Yeah. Awesome. Garish, Tilo, do you guys have any other pressing questions for Tilo?
For me, yeah, just it was great. I appreciate it. I'm gonna just do some work with wrk2. Well, inshallah, with wrk, and once we have some questions, we can have follow up over Slack or something. Yeah, just.
Absolutely, yeah.
I think
Just
it was really.
I'm very interested in having that. It's just that I currently don't have much time for myself to put into that. I'm so happy this is happening. I didn't say that during all the meeting, but it's really amazing.
Yeah, appreciate it.
Quick lesson learned maybe from part of your experience. So as you guys ran as you ran your performance tests within Packet, we're all signed up and approved to go and take, I think it's about 20 nodes, and go and and when we're ready to run some tests. And I figured I'd ask, how well did they facilitate? Well, I guess in your case, you didn't want them to facilitate the provisioning of Linux or of Kubernetes. You brought your own, and so in our case, you know, the tests are agnostic to that. And so, what tooling did they give you in terms of metal machine management, out of band management?
So Packet has an API, which a provider for is available for Terraform. Locomotive for bootstrapping uses a lot of Terraform. So we basically got Packet support more or less included. And then we helped a customer to migrate parts of the application out of AWS to Packet, because the customer had a better offer basically for some of his workload. And that helped us a lot to really flesh out and iron out the Packet support in Locomotive. It's one of the primary platforms that we support. And like nothing's manual. You start from basically green grass, from nothing, and the API allows to order servers and to interface with them to get your stuff bootstrapped and deployed. And yeah, so fortunately we did that work before the benchmark came around, and we were all set. We were just you can bootstrap a Kubernetes Locomotive cluster in a matter of minutes on Packet.
Okay.
So you just it's one configuration file which that's the basics that you define how you want your cluster arranged, and then you issue the right Terraform command, and Locomotive will do the rest for you.
Nice. Okay. Tilo, man, I'll let you. Yeah, this has been great. This has been. We'll come back. I think I got through all my questions. So we're gonna see what kind of things we can do with your wrk2. See if we can get some of that JSON that Sako you got going for wrk with Tilo's stuff.
Yep.
All right. Very good.
Thank you. That was fun.
Yeah. No. Yeah. Talk to you very shortly. If time permitting, I'll spark up a conversation with Chris as well. Actually, that would be like, you said a couple of things that I hadn't considered before. And one of those being like Meshery being included as a component of Flatcar Linux.
It's the Linux distribution is Flatcar, and on top of that is Locomotive as the Kubernetes distribution.
And so that most appropriately then probably, well, I guess really to the extent that people are using Meshery, that would be used in context of both Locomotive and Flatcar, and so. But literally, like that component packaging, is that would be at the Flatcar level, if you will.
No, that's all Locomotive level. Flatcar is the plain Linux image basically that you fire up, and it's a very minimalistic thing aimed at containers and Kubernetes, and so it contains the bare minimum, and it aims for stability, security, and freshness. Like we're trying to be up to date with everything.
Okay. Yeah, I guess in some respects you sort of hope that CoreOS Linux does go by the wayside, because then Flatcar Linux will be the thing, man. That'll be, So. All right, fair enough. Great, Tilo, man. Great to you. Good to talk to you very soon, man.
Looking forward. Thanks for having me.
Thank you very much. And yeah, I will share recording. I guess, Liv, you need to go back and sometime to check some brainstorming questions.
Really looking forward to that. Thanks, Sako. Bye, Girish.
Thank you, too.
See you, folks.
Bye.
Thank you, guys. Bye-bye.